Have you ever wondered what it would take for a spacecraft to survive temperatures hotter than the surface of the Sun while plunging back into Earth's atmosphere? Imagine a vehicle, the size of a skyscraper, re-entering at hypersonic speeds, wrapped in flames with temperatures soaring above 1500 degrees Celsius. That is not science fiction. It's the challenge SpaceX is facing right now with Starship. And Flight 10 could finally prove whether their new Heatshield technology can truly endure the impossible. For years, Elon Musk has been vocal about the toughest part of building a fully reusable spacecraft, and surprisingly, it isn't the giant engines. It isn't the massive stainless steel tanks, and it isn't even the challenge of in-orbit refueling. The hardest challenge, according to Musk, is the Heatshield. In his own words, creating a reusable orbital heat shield that works reliably is one of the most brutal engineering problems humanity has ever tried to solve. Think about that for a second. Humans have been flying to space for over 6 decades. Yet here we are in 2025, still struggling with a technology that was first tested during the early days of the Mercury and Vostok programs. So why is this such a massive problem? After all NASA's Apollo capsules came back from the Moon, survived fiery re-entries, and astronauts lived to tell the tale. Modern spacecraft like Orion and Dragon already have heat shields that work. Shouldn't SpaceX just copy that technology and move on? The truth is, it's not that simple. All those older heat shields were mostly ablative, meaning they burned away during re-entry. They were designed for single use, not for reuse. Apollo's Avcoat Heatshield was fantastic, but it could only handle one flight. Even Orion's Heatshield today is still closer to expendable than truly reusable. SpaceX, however, doesn't want a one-and-done spacecraft. The whole Starship architecture is built around the idea of rapid reusability, just like airplanes. If you have to rebuild or completely replace a heatshield after every mission, Starship fails its entire purpose. That's why this is such a groundbreaking challenge. SpaceX's answer, so far, has been a unique combination of stainless steel structure and ceramic heatshield tiles. Each tile is lightweight, incredibly strong, and designed to snap onto the Starship's hull like Lego pieces. If one tile is damaged, it can be replaced individually without tearing apart the entire system. On paper, it's brilliant. In practice, it's been messy. Starship test flights have shown that the tiles can survive insane heat loads. But the problem isn't just the heat, it's the vibration, the aerodynamics, and the constant stress of re-entry. If a single tile shifts out of place or cracks, superheated plasma can sneak inside and destroy the entire vehicle. It's like wearing armor made of thousands of tiny plates. The protection is only as good as the weakest link. Flight 5 gave us the first real data that these ceramic tiles actually work. Despite catastrophic failures elsewhere, the heatshield tiles endured re-entry conditions far better than many skeptics expected. Engineers were able to analyze the data and confirm that the material choice was sound. But one flight isn't enough. What SpaceX really needs is a successful mission where Starship not only re-enters safely, but also remains intact enough to be flown. That is why Flight 10 is shaping up to be one of the most important Starship tests yet. During the recent Takeover 2025 event in California, Musk revealed just how seriously he takes this challenge. He spoke at length about heatshield development, admitting that it has consumed more engineering hours than nearly any other subsystem of Starship. Interestingly, he didn't spend as much time talking about vibration resonance, cryogenic transfer, or even Mechazilla's tower catch. Instead, his focus was almost entirely on the heatshield, and for good reason. If it fails, everything else fails. Let's put this into perspective. The temperatures Starship will face on re-entry reach levels of 1500 degrees Celsius, which is about 2700 degrees Fahrenheit. That is hotter than molten lava. The friction with the atmosphere creates a plasma sheath around the vehicle, essentially turning the spaceship into a glowing comet. In that environment, even the smallest design flaw is magnified. Rivets, gaps, or edges can become weak points. The stakes are incredibly high. NASA has dealt with similar problems before. The space shuttle famously used ceramic tiles as well, and while they worked for over 100 missions, they were also notoriously fragile. It took weeks of inspection and replacement after every flight, and we all remember the Columbia disaster in 2003, which was caused by damaged tiles. SpaceX's engineers know this history all too well, which is why they are trying to design a tile system that is not just protective, but fast to inspect, easy to replace, and able to survive multiple missions without constant maintenance. So far, SpaceX has been iterating at lightning speed. Tiles have been tested in different shapes, thicknesses, and materials. Some are hexagonal to reduce gaps, others have flexible mounts to handle vibration. The team has even experimented with different coatings to reflect heat more efficiently. Every test flight teaches them something new. Every explosion, as frustrating as it looks from the outside, gives SpaceX data no one else has ever collected at this scale. But why does this matter so much for the future of space exploration? Because without a reusable heatshield, interplanetary travel is simply not economically viable. To land humans on Mars and bring them back safely, you need a spacecraft that can take off, re-enter, and fly again multiple times. Building a new heatshield from scratch for every trip would be ridiculously expensive. It would be like building a new airplane every time you fly across the Atlantic. Musk's dream of a multi-planetary civilization hinges on cracking this problem. Flight 10 could be the mission that changes everything. If the new heatshield design holds up, it won't just mean Starship survived another test. It will mean that architecture is finally maturing into something that can actually achieve rapid reusability. It will mean SpaceX is one step closer to making Mars settlements a reality. It will also silence a lot of critics who still believe Starship is an overhyped pipe dream, but let's not pretend success is guaranteed. This is rocket science, and history shows us just how brutal it can be. Even tiny oversights can cause catastrophic failures. SpaceX has already lost multiple prototypes in dramatic explosions, some due to engine issues, others due to aerodynamic stress. Each time, though, the company learns, adapts, and rebuilds faster than anyone else in the industry. That relentless pace is what makes people believe that if anyone can solve the heatshield problem, it's SpaceX. There's also the question of how this compares to other systems. NASA's Orion is robust, but expensive. Boeing's Starliner has its own heatshield design, but has yet to prove itself in operational service. China and Russia are both working on their next-generation capsules, but none are attempting the kind of fully reusable heatshield Starship is aiming for. In many ways, SpaceX is trying to leapfrog decades of cautious progress and jump straight to the endgame, a spacecraft that can fly to orbit, re-enter, and do it all over again like a commercial jetliner. The irony, of course, is that the most advanced spacecraft in history is struggling with the same core problem as the very first capsules from the 1960s. It shows just how unforgiving re-entry physics really is. Yet that is exactly why solving it will be such a monumental achievement. So, as Flight 10 approaches, the world will be watching closely. The launch itself will be spectacular, but the real suspense will come during re-entry. Will the tiles stay in place? Will the vehicle remain stable as it slices through the atmosphere? Will the heatshield prove that it can truly handle the punishment and still be ready for another flight? These are the questions SpaceX must answer. Elon Musk knows the stakes better than anyone. In his own words, if they can get the heatshield right, everything else becomes much easier. Propellant transfer, tower catches, even Mars colonization. All of it depends on first surviving the fire of re-entry. That is the gateway to the future. So when you see that glowing Starship streaking back down toward Earth, remember what's really being tested. It's not just steel, tiles, and engineering. It's the very idea of making humanity a multi-planetary species. If Flight 10's heatshield succeeds, it won't just be another milestone for SpaceX. It will be proof that we are edging closer to becoming a civilization that can live beyond Earth, and that, more than anything else, is why the world is waiting with such anticipation.